Now let's move from the word equations into the actual chemical equations. Now what the difference between word equations and the actual chemical equations is the chemical equation includes the quantitative as well as the qualitative information. Okay? All chemical equations must have the same number and types of molecules on each side of the arrow. So we see our word equation that we have here, where it's hydrogen gas plus oxygen gas produces dihydrogen monoxide, and then we see the actual chemical equation below it. Now the main thing that I'll caution you here, the main thing that usually people mess up with in going from the word equation to the actual chemical equation is that you have to write the chemical formula correctly. And this comes back to what we learned last semester on how to write chemical formulas. So we have to be able to do that right to be able to transfer it from the word equation to the chemical equation. So we'll look at this. Here's our word equation. We have solid magnesium plus oxygen gas. We see that it produces magnesium oxide. So in writing the actual chemical equation, all we have to do is for our elements, we write them down. We put magnesium and we put oxygen. Now anytime you write magnesium or you write magnesium and oxygen, those are single elements. They're not bonded to anything else. Anytime you write single elements, you have to check, is it a diatomic? And remember, we remember those on the periodic table by Brinkelhoff. Remember that they're bromine, ClHO. F. So Brinkelhoff. Anytime you write any one of these by themselves, they're diatomic, so they have to exist bonded to itself. So we check, is magnesium a part of this Brinkelhoff? In which Brinkelhoff, all it is bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. Okay, is it a part of that? No, it's not. So it's just written as magnesium. Oxygen, is oxygen a part of Brinkelhoff? Well, yes it is. It's right here. So instead of writing just an O, we have to put O2. Okay, now these are gases, so we put a G representing gas, or sorry, magnesium is a solid, so we put our S there, and then oxygen is a gas, and then it makes magnesium oxide. Now this is a compound. Okay, we'll move over, we'll Brinkelhoff down here. Now magnesium oxide is going to be a compound. Now we have to write the correct chemical formula. So magnesium oxide, it is a ionic compound, and it exists of magnesium bonded to oxygen. Now remember, when writing ionic compound formulas, we always have to crisscross. So we look on the periodic table and we see that magnesium has a +2 oxidation number and oxygen's -2. So we go ahead and crisscross, bring those guys down. Remember, the positive and negatives cancel out, so we get a 2 and a 2. And since they can be reduced, that 2 and a 2, they have a 2-to-2 ratio, which is the same as a 1-to-1 ratio. So we just get MgO. Okay, and we said earlier that would be a solid because it was that white powder. Let's look at our next one. So we have liquid dihydrogen monoxide, that's that water. We have hydrogen gas plus oxygen gas. So let's go ahead and write this. Liquid dihydrogen monoxide, it is a covalent compound. So di means 2, so we would go H2. Monoxide means 1 oxygen. There we go. It's a liquid, so we put an L there. And it produces our hydrogen gas and oxygen gas. So we put hydrogen plus our oxygen. Okay, when we write this, we have to represent it. Is it a part of Brinkelhoff? Look back at this example. Yes, they both are. There's the H, there's the O. So instead of just writing H and O, we have to put H2 and O2. And we would get this as our final chemical equation. Get it where you can see it. And that would be our final chemical equation for that, from that word equation.